What is going on, YouTube? Welcome back to my channel. This is Darian with Darian the Dev, and you guys are tuned in for week 5, officially week 5 of the Career Progression Bootcamp, where myself as a software developer and some colleagues of mine, we work remotely. They're also software developers, and we're in different spots, obviously, and we link up here every single week to go over what we do to get better and to progress in technology as software developers, and basically show you guys the curriculum. You want to know what to study, what to learn, what you should be doing to get better if you are either in a coding boot camp, if you just got out of a coding boot camp, or if you're in your first job as a developer, you're trying to get your second job, or whatever, if you've already been a developer. Whatever the case may be, I think it's good to just see how we go about kind of just staying up to par where we want to be, and also just how the power of working remotely can really help you just stay sharp and hold each other accountable in tech, because things change so fast. We're always learning new stuff. So yeah, guys, I appreciate you for tuning in. If you're here with me, make sure you guys like, share, and subscribe. It really helps me to stay motivated to keep making videos like this for you guys. And in just a second here, we're going to start officially at 4. So I'm going to go ahead and get ready to call the first guest in. I'm really excited though, because in this one we have so I'm going to be talking about a lot of C# stuff today. We're going to be talking about LINQ specifically, and then we got func, data type, we got lambdas, I should say. We got some interface stuff to talk about in C#, and then La is going to have some networking stuff for us. So I'm super excited. It's 4 o'clock. I'm about to go ahead and call her. Sit tight, sit back, and get ready to soak this up, guys. Please make sure you leave us any comments or anything as we go through this stuff. We would be glad to answer everything live for you. All right, let me go ahead and get live in here.
Hey.
La, what's going on, girl?
Not much. How you doing?
Good. Let me see. All right. Got my slides up. Should I just go ahead and dive in? Go first?
Yep, go ahead, dive in.
All right. Let me share my screen really quickly. Options. Lab demo. Okay. And let me know, La, if 1 second. Okay. I don't even know. I'm not sure. Are you watching the stream on YouTube or?
Yeah. I'm trying to pull up right now.
All right, cool. So if you can, just let me know if you can see my my slides. I gotta pull the stream up on my phone really quickly. Oh no, we're good. Y'all see it? Okay, cool. So I will go into presentation mode. And boom. I guess I'll leave myself hanging down there. You can see. All right, cool. So for my slides for this week, for my topics, like I just said really quickly in the intro, we've got LINQ, Lambdas, and C# interfaces. So this is all pretty much, I don't know. So Lambdas I know are used in other languages. LINQ I know is specifically a .NET thing. And interfaces is also general object-oriented programming stuff for anybody out there watching. So we're going to start off with LINQ. All right, so the initial problem with LINQ, and I know we had talked about it a lot, but so this is what I'm curious if other languages have something like this. So the problem they had initially when they created LINQ for C#.NET was that you could have data coming in from all different sorts of data sources. You could have a database, you could have an Excel sheet, CSV file, you could have a file coming in from a file system, you could have a straight up object, you could have XML, you could have a ton of different ways you could be receiving or manipulating data. And in C Sharp, the C Sharp developers wanted to make a unified way to query all these different types of data sources that you could possibly run into, but they wanted to be able to do it the same way. So basically, LINQ is a way to do that. You can do it all. You can query all these different data types using one unified format. So the two different ways we can use LINQ is with Lambda expressions, or we can use query syntax. And they kind of overlap just a little bit, but you'll see what I'm talking about. So lambdas are used like anonymous functions, so that you can just not have to specify any input values. And yeah, we're about to see some examples, but it gets really interesting. So like right here, if we had a list of numbers, and we wrote this lambda. So all right, so this list, for anybody who doesn't have a list in their language, if it's not called a list, just think of it like basically an array. So you have an array of numbers, a list of numbers, and this right here, this select statement, well, what we see written inside this select statement is a lambda. So the select statement is LINQ, and what we're using to specify what we're selecting is a lambda expression. So the X this is what we mean by anonymous. So we could give this any name. X could be whatever we want to call, again, this anonymous function. And then all we have to do is, or not anonymous function, but how, all right, let me think about this. So I don't tell anybody anything wrong. I'm thinking about how I want to say this. All right, so we're selecting something. So if we're using LINQ, we're querying something. So we're selecting something from a collection. In this case, it's a list, or like I said, an array. It could be anything, a dictionary, whatever, any sort of collection. So the function doesn't have a name. It's an anonymous function. So X is just the name of each item in our query or whatever, our collection. So what we're saying is, on each item, we're going to multiply the item by itself. So in this case, since we have a list of numbers, for every item, we're going to multiply the number by itself. So the output of this is going to give us each of these numbers one by one multiplied by itself. But again, we don't have to do anything special. We can just write it right inside of this this select method while we're using LINQ. So LINQ gives us access to this select, and then we're about to see some other examples of what else LINQ gives us access to. But basically, it's almost like SQL, but inside of C# code. But you can use the SQL syntax to query any type of data. All right, so this says why it matters, in case you can't see the top part right there. So this first part is an anonymous method. All right, so this is like if we were to hard code what we just did without using a lambda expression, we would have to hard code it. So we have a list of cities, or an array of cities in this case, and again, we're trying to query a collection or query some list of data. So we're trying to look inside of cities, and we're trying to grab where some city starts with an L. So this is how it would look if we wrote an anonymous function. This would just be ignore any of the like ugly syntax stuff. Don't worry about delegates right now, but this would be the syntax for us to do the same thing we just did, but using an anonymous function instead of a lambda expression. Whoa. All right. All right, so the second one down here would be a named method. So in this case, we would call a method on the where. So again, where is coming from linked. That where method, anytime we see something that reminds us of SQL, that is coming from LINQ. So on a collection, LINQ gives us access to a where method that allows us to query this collection using a whole bunch of variety of ways, which is what we're going through one by one right now. So I'm just iterating that because this used to confuse me. So I want to make sure that hopefully makes sense for anybody listening. So now in this where method, we can query it different ways. So up here, we actually wrote a delegate method. We wrote our own method basically. We used, a helper method called starts with, but we wrote our own method up here. Down here, we're writing a helper method. So or a name method. So we're gonna call it. So same thing here. We're trying to just get all the cities that start with L, but we're calling it inside the LINQ method. In this case, that's a name method. All right. So that again compared to this, where in this case we're using a LINQ method, and then we're doing like our logic or our behavior. We're using a lambda. We're using variables basically. So that same thing using a lambda expression would look like this. So we'd say cities. So inside of cities collection, cities array, cities IEnumerable, whatever type of list it is. For every, S, whatever, this could be anything. S could be anything. S dot starts with L. So the same way we just did that in the we still use starts with, but we're just talking about the way we used it. So here we wrote a method, anonymous method, right inside of the where method. We wrote another delegate method. For the name method, we passed in a method that we wrote, a helper method, to the LINQ where method. But when we're using the lambda expression, we can just use a variable and just use a variable for every item in our collection, and then we can just call that that starts with right on every element right there. Starts with L, and this would be our output from that. And I ran this on my computer on my machine, y'all, so I know the code works. So that output is actually from my machine. So you can see that all we have here is London and Lisbon, and you can see that we still call a helper method, but we're calling it directly from a lambda expression on every element, and we get London and Lisbon. All right, so now we'll talk about the func data type. Well, any questions about that? I guess it's a good time to stop in.
Oh, sorry, no, I don't have any questions about that.
All right, cool. All right, so now we got the func data type. All right, so again, I thought this was cool. I think other languages have stuff like this as well. It just might be called something different. But in C#, func is a type that allows us to create variables that point to methods. So we can create the structure of a method using a func, and then we can pass that variable name around and always know that the method will behave as we expect it to behave, if that makes sense. So in this example right here with a square, right, just some simple basic like math stuff. So the first input in this case is an integer, and that means that this method takes one integer into it. The last parameter is always the return type. So in this case, we're going to give this method an integer, and it's going to return us an integer value as well. So in order for us to square something, we need to pass it a number, and then it's going to square that number, x times x, right? So lambda expression here. So this could be anything, this could be anything, this could be named anything, right? But this is going to be an integer, this is going to be an integer, and this is going to be an integer. So yeah, so we can just square values like this, and then with adding, we just add an additional parameter. So now our inputs are going to be 2 integers, and then our output is going to be, our return value will be an integer. So now instead of just x, we have x and y, and we want to add x and y anytime this add function is called. So down here, console write line is the same thing as just console.log if you're coming from JavaScript. So or any other background if you're printing something in Python or Ruby. So we're just writing to the console our square method, and we pass it 3 because we have to pass it one integer value, and it should square 3 and give us 9 down here in the output. So if we call the add method, we have to pass it an integer and an integer. So we pass it 3 and 5. It has to give us an integer back, so it gives us 8. And then to even get busier with it, to show you how deep you can go with this, if we call add with 3 and 5 and get 8, and we square 8, we get 64. So we can do this with up to 17 parameters, which is pretty crazy. So these can get really insane. I don't even know what you would need that many parameters for, but it would get crazy. I've seen stuff like that at previous jobs, but yeah. Let's see. The last parameter describes the return type. Yep, and these can be passed to LINQ delegate methods to add additional functionality in logic. So we'll see examples of that. So, all right. So now query syntax. So this is the other way of being able to work with LINQ. So we just talked about lambda expressions. This is the second way, the query syntax, which will probably look very similar to SQL. You'll notice it looks similar to SQL. So again, this header says query syntax. If it's cut off on the stream, I don't know. All right, so again, we got a collection of cities or an array of cities, list of cities. Again, I'm just going to keep reiterating that. It doesn't matter if it's just a string or a string array. This could be any sort of collection of anything. And we are going to return an INumberable string, and we're going to filter out from the cities that start with L and are less than 15 characters. But as you'll notice, we're using the query syntax now. So we could have used a lambda expression to do this like we did before. But now you'll see this looks much more like SQL. And the purpose of them giving us both lambda expressions and the query ways of working with LINQ is for readability. So lambdas can get pretty crazy with all those variable names getting tossed around, as you guys saw, X this, Y that, and all these different crazy variable names, and how busy those can get with 17 parameters being used in funcs and all different types of stuff. It can be really hard for people that aren't familiar with the code to know what's going on if they jump in and start trying to read it. So they created the query syntax to try to make a uniform way that all developers are basically familiar with, that can query multiple data sources in a way that will be easily readable no matter what data source is coming from, and no matter if the developer has ever worked in C# or .NET before. They wanted to make something that people would understand, basically. So again, the outcome is not going to be any different. As you can see down below, we just have London and Los Angeles printed out, but as you can see, the syntax looks very similar to the database query language. So it looks like SQL. So we use the from clause here, and from every city in cities where the city starts with L and is less than 15 characters, we want to order it by, so basically alphabetize it, and we have to select the city, or we have to end it with the select statement. So we'll see that as well. So key takeaways about query syntax are, so I'm looking at the clock, y'all. I'm like 15 minutes in, so I just want to make sure I'm on par here. I don't want to take up too much of last time. I want y'all to get everything she's got good for y'all on the networking side. So the takeaways from query syntax are that you must start with a from clause, and this is the same way that you would work with SQL. So a lot of this stuff just is interchangeable. I think that's why it's cool to kind of see how things overlap. So the query syntax always ends in either a select or a grouping statement or clause. The query syntax can be used in place of lambda expressions when you're using LINQ. So again, you're not limited to just using one or the other. You can intermix them if you want. You can use lambdas in some places and use query syntax in other places. It's completely up to you. System.LINQ. This is basically for the .NET developers. It is the namespace or the package that has access to the query operators like the filter, sort, join, aggregate, select, where, all the stuff that we just did. You will not be able to do that in your project unless you put a using statement in your project to say using system.LINQ. And those are also extension methods as well. If you want to look more into that, you can go Google extension methods and read up on that stuff. So those methods, the filter, sorts, the aggregates, all that good stuff, the selects, the wheres, they know what you want to do, but they don't necessarily know how you want to do it. So that is the purpose of the lambdas. The way they wrote the entire package or namespace. I don't know if I'm using the right word there, but system.link is written in a way of using a bunch of interfaces that allow you to work with all these different data types with an abstracted syntax, basically. So again, the where and select and all that stuff, it works whether you're using XML or JSON or like you just saw a list or something like that. But you have to specify the behavior of how you want it to select or how you want it to filter, because it's abstracted away so that you can supplement that with any data type, or data source, I should say. So yeah, that's how lambdas kind of coincide with the query syntax and LINQ operators. All right, last section here, interfaces. All right. So in this example of an interface, we're going to be talking about a polygon. All right, just a regular polygon. So it has to have 3 or more sides. All the sides have to be the same length. They each have a perimeter and they also have an area, right? So I know this might seem like a very basic elementary example, but I wanted to make this as understandable. It's less about the example, it's more just about being able to understand the concept of the interface and what we're doing with it. So wanted to keep it super simple. So obviously at the bottom right here, we can see that in order to get our perimeter and our area, we're going to need a couple different ways of doing that. And the ways that we get the area are going to be different. Based on the right side a triangle or the left side a rectangle. So the perimeter, the way we get that is the same. It doesn't matter if we're working with a rectangle or a triangle. The way that we get or calculate the perimeter is going to be the same, but the way we get the area is going to be different based on the shape. So keeping that in mind, we're going to see how interfaces help us do that, and we're going to look at other ways of doing it without the interface. So I want to try to hopefully make the whole interface thing clear, because the first time I learned interfaces, I learned it really quickly in Bootcamp, and I felt like it didn't really stick with me. So we're going to look at some examples of not using an interface and implement this functionality. Then we're going to come back and implement the interface, and hopefully that'll bring the concept all the way home. Okay, so an interface describes a group of related functions that belong to any class, period. High level, that's all we need to keep in mind. Interfaces describe a group of related functions that can belong to any class. All right, so the word describe is very important here, because we're going to declare our methods or our properties, but we're not going to implement any of our methods. We're only going to declare them in the interfaces. Always. It's going to be up to whatever class is using our interface to decide how that gets implemented. So just keep that in mind as we move forward in these examples. But that's really all you need to know, though, in terms of the difference between a regular class or something else in an interface. All right, so a concrete class is going to describe functions that are functionality of objects that it can be used to instantiate. All right, so I know this was 2 back-to-back definitions, but we're about to get into some examples. But again, we just have to kind of understand those definitions first before we can make the examples make sense. All right, so example of a concrete class. So again, describes the functionality of the objects that it can be used to instantiate. Okay, so in this case, we have to describe the functionality. So we're creating a polygon here, and we're just calling it a concrete polygon class so that we know we're looking at a concrete class, but this could be just called the polygon class, whatever. But in this case, you can see that, so we start off declaring the 2 properties, the number of sides, I'll put my mouse up here so you guys can see where I'm at. So number of sides and the side length, how long the sides are, right? So these are the two properties of our polygon. So we have to declare that obviously in our class. Next thing is we have to set those values. So we have a constructor here. So whenever you create a polygon, it's going to have a number of sides and it's going to also have a length. And so right here, we're going to, again, go back to the definition one more time. Describes the functionality of the objects that it can be used to instantiate. So we have to describe everything in this class. So in this case, for our get perimeter, we have to describe how we get the perimeter in this class. So we're going to get the perimeter by multiplying the number of sides by the side length. So down here for our area, we can't implement this in a polygon because we already said that, right? It could be either a triangle or it could be like a rectangle. So we can't just implement that right away because that can change. So we need to make it flexible for any child classes that get this concrete polygon class or that inherit from this concrete polygon class. So virtual is a C# thing specifically, so I'm not going to spend too much time on it. You can look up the virtual keyword on your own if you want to, but we're just throwing an exception here, basically saying that this has to be implemented by a different child that is using this method. So over here, this little piece of code, we create the square class, okay? And the square class is going to inherit the concrete polygon class from over here, right? So now it automatically has this get perimeter because we inherit that. It has this method already. It knows what to do. It knows because we declared the functionality right here in the concrete class. But for this get area method, we have to override that over here, right? So virtual is basically a way of allowing us to override a method somewhere else. So over here, you'll notice that because we're using the get area method in a different class, we have to use the override keyword. That's what allows virtual to allow us to use this override keyword and implement our own functionality over here. It's a bunch of C# jargon, but you can look. These are topics you guys can look into on your own. And so we implement over here how we do that. Up here, this is some very, very weird syntax. It's not super important other than the fact that for any square we create, a square is going to always have 4 sides. So the base class of any square we create is going to automatically get 4 sides. So whenever we create a square, we just only need to pass it a length. So that's basically all that's saying. So now this is actually, the code that runs our program. So all we do is declare a new square, and like we just said back here, we only need to pass it a length. Anytime we instantiate or create a new square, we only need to pass it length. It already knows the number of sides. So we come over here, create a new square, pass it a number of for the length, and then we just call, again, this is just printing to our console. We can just call square get area, but get area comes from, in this case, the polygon class, the concrete polygon class. We just give it the functionality inside the square class. And same thing with the perimeter. We don't even define or declare the perimeter method in the square class at all. It's coming from the concrete polygon class, which is being inherited here. So when we call get perimeter, again, it's coming from our concrete polygon class. So when we do that, we get 5 times 5 is 25 for the area. And if we go back, where is 5 times 5 coming from? Sides times the length. So that's how we get that. And then let me see. And then same thing with get area. Whoops. Oh my goodness. Sorry y'all. I'm going nuts over here. But our final output is 5 times 5 and 5 times 4 for the length times number of sides. And we get 25 and 20 printed out in our console. So that is us declaring everything inside of a concrete class. And then inheriting that into a child class. The next thing we have is an abstract class. An abstract class, and I'm at 28 minutes, so I'm going to try to wrap it up really, really soon. We got just like a few more slides to go. So the abstract class is designed to be inherited by child classes that either implement or override its method. So every single method in an abstract class is meant to be overridden by the child classes that it inherits. So what we just saw before in the concrete class only had one method that we had to override because that was the only one that could change for any class that would implement that concrete polygon class. But in this case of an abstract class, every single method that we write in the abstract class is going to have to be implemented differently in every child class. So we'll see that here. So everything's going to stay the same. On the left hand side, as we're looking here, I put my mouse back. All this stuff right here stays the same, right? We just instantiate an abstract polygon, same thing as the concrete polygon. Same exact properties, number of sides, and side length. And even this is the same. Getting the parameters the same. But what we're going to do differently is we're going to make an abstract method right here for getting the area. And then over here for a triangle, we're going to do the same thing. We're going to implement or inherit the abstract polygon for a triangle, and we're going to override this abstract method of get area and then tell it how to get the area of a triangle specifically. So same thing here. Triangle automatically gets 3 sides, and then we just pass it a length. So it looks very similar, the process, to a sorry y'all, I just went blank. A concrete class. It looks very similar to a concrete class, but the difference is if we had more methods, like obviously all polygons are gonna have a perimeter, but if we had more methods we wanted to run on this, like other than just the area, they would all just be abstract methods, and we would have to implement them all in the class that implements it. You know, I just wanted to keep this one simple. So it's very, very similar at the end of the day to what we just saw. So again, if we create the triangle and we say the length is 5, you'll see that for the area we get, you know, a decimal, and then we get for our perimeter we get 15, 3 times 5, because every triangle already has 3 sides. Okay, so now for the interface. So how does an interface help us alleviate doing what we just did? So when we think interfaces, we want to think either a contract or an agreement. All right, so meaning that all the child classes that have or that implement our interface, they have to all know what the contract or what the agreement is. So we cannot use access modifiers, and we cannot decide the implementation inside the interface. Well, we cannot decide the implementation inside the interface because that basically goes against our contract. We have to let the child class decide how it wants to use the method, but the child class has to use every single method. And as far as access modifiers, in order for the child classes that use our interface to know about our methods, we cannot actually put access modifiers like private or protected on our methods in the interface. So if we do that, the child class won't have access to that method, and then it won't be able to fulfill the contract or the agreement of the interface. So we cannot use any access modifiers. We will not ever implement the actual functionality of the methods in the interface. And we can always think of it like a contract or an agreement between the child classes that implements it. So I really hope that makes sense. I really hope that I'm trying to make this as lean and straightforward as possible. So I really, really hope that that's at least a good starting point. We're about to see some examples, though, that might hopefully help this build on this. Okay, so in the same example that we just saw with a concrete and an abstract class, we're going to do it with an interface right here. So in this case with the interface, we are just going to give the interface the properties that each individual class had, or that are like our abstract class or our concrete class had. We're just going to give those properties to the regular Polygon interface. And we're also going to give it the declaration for get parameter and get area. So we're going to say anything that uses interface has to have a get parameter method and also has to have a get area method, but we don't write any functionality or any code in the interface. Why? Because it's not part of the contract. The contract says that the child class has to decide the functionality or how it uses the methods, but the child class has to use whatever methods that the interface has. So that's how the contract works back and forth. That's the agreement. So we're not going to give it any functionality. We're not going to use any access modifiers on here. We're only going to declare the data type that it should return, and that's it. And give it a name, and that's it. Now when we see the child classes, we'll see how this gets implemented. So if we create an octagon class, the octagon class is going to inherit from the polygon, the regular polygon class. And you can see right here that we have to, down here, so first we have to instantiate a polygon. So we have to say that a polygon has 8 sides. So we have to set the number of sides to 8 anytime we instantiate a polygon. Octagon, because that's what makes the octagon. So we have to set that in the constructor. So every time, because of this line right here, every time we create an octagon, it'll automatically have 8 sides. So whenever we create an octagon, we just need to pass it a length the same way we did a triangle and a square, and it'll automatically know how to get our area and our parameter based on the number of sides it has, which is 8 by default. But the methods that we declared over here in the interface, the get parameter and the get area, we have to actually write the functionality in the child class, the octagon class, because that's the contract. We have to use the get area and the get parameter methods from the interface, but we have to use or decide the functionality in the child class over here of how we want to actually do that. So that's the premise. So if we wrote more classes over here, for example, if I wrote an extra method in this interface right now, and I didn't implement it over here, my code would break and this wouldn't work anymore. So anytime anything changes in this interface, it's going to also affect anything that inherits from that interface. So it's a contract. We have to keep them in cohesion with the contract. So same example in our program, we create a new octagon, tell it how long the length is, and then we get the area, get the parameter, and then you guys can see what the output is from that. But that is the difference of how we use an interface, and that has a lot of different implications for just keeping your code maintainable, readable, and yeah, there's a lot of reasons for it. I guess we'll talk about it right here in the summary. So at 35 minutes into the stream, I'm going to summarize that we talked about LINQ and how it allows you to query multiple data sources in the same way in C#, and it's very similar. We have multiple ways of doing it, so we can use either the query syntax or we can use lambda expressions. So there's multiple ways of querying multiple data sources in C#, all using LINQ. Func is a C# data type, or a type that allows us to create variables that point to methods, and then we can pass those methods around in other places in our code. It guarantees that that functionality will always behave a certain way, or that method will always behave a certain way. We declare the inputs that it has to have, and we also declare the type of return value it has to give us, and we know that that method or that variable name will always give us the return value that we expect. Again, they can be passed to LINQ delegates to add behavior to methods. And then we talked about lambdas and how those can be thought of as anonymous functions. Concrete classes describe the functionality of objects that it can be used to instantiate, while abstract classes are meant to be overridden and implemented in the child classes. With interfaces, there are only declarations. We don't do any implementation in an interface. We only declare the properties or the methods in the interface. The child classes have to decide how to implement it. And interface, again, is a contract or an agreement, and all the classes must know about the agreement. So we cannot use access modifiers like protected or private or anything like that. There it is. Yeah. All right. Any thoughts, feedback, questions?
Yeah. So I guess in the interface, I think in your example, you had like a couple of attributes. Can you not have attributes in the interface, or they just can't be private or protected?
Yeah. No, you don't. Like by attributes, you're referring to like number, size, the length.
Yeah. Variables.
Yeah. Yeah. You don't have to. No.
But
if you just want to have only methods, you could do that.
Okay. And so I guess that's the question would be, what would be the use case that someone would choose to use, like a concrete class versus an abstract class versus an interface?
So I think it depends on like keeping your code dry, right? So if I know that I'm gonna have multiple things and I'm gonna have similar functionality, so in this case shapes, and I don't know why that would be important for a program, but if we had a ton of shapes that our program needed to utilize, and we know that we're gonna have to again calculate all these different things for all these different shapes, then it might be easier to just create an interface for each type of shape you're gonna have, in terms of like how we had polygons or I don't know, I guess obtuse shapes or something like that, obtuse interface. But either way, you might have 3 or 4 interfaces that could take care of all your different types of shape classes versus having a whole bunch of concrete classes that pair up one for one with every shape that you might have. So it's really, I think it's just a use case thing. Like if you don't need a bunch of if I wasn't going to do something over and over and over and over and over again in my code, if I wasn't going to continually create, some sort of objects over and over again, I might not need an interface. It might just be easier for me to come back and see that I have a concrete class that is just being inherited by a child class, and I can just make that relationship easier than trying to figure out like, okay, why did I make this interface? Why is it implemented here? So I think it's really just a readability difference, because functionality wise, it's all accomplishing the same thing.
Okay. All right. Other than that, I don't have any other questions. It was, well presented.
All right. Appreciate it. Let's go ahead. Which one do you want to start off with on yours?
Let's start with networking.
Okay. All right, getting you pulled up right now. All right, so I'm giving this 1 second to load up. Hopefully we'll be able to see. All right, so I'm giving this 1 second. Checking the stream. Yep, looks like it's there. Can you see it, La?
Yeah. Wait, I see the computer. Yeah, I see it.
All right. Yep. So I think it's still loading the rest of the slides. So I'm gonna go into presentation mode once it loads. Yep. Come on. There we go. Alright, so computer networks. I'm gonna go ahead and jump to the first joint right here.
Alright. So this is just pretty much, I guess, the agenda of it. So I don't know, it's interesting as I was going through it. This is sort of definitely more of a what you would learn in the foundations, I guess, in computer science. I definitely trimmed out a lot of information that was a lot of extra, just historical information, because I just didn't think it was enough, didn't have enough time to get through all that. But it definitely just gives you a lot of the basics of what networking is. So we'll start with the agenda. The agenda, we're going to talk about what is a network, the hardware of network, software of network, and the reference models. That'll be what we talk about in the first chapter. So we can go to the next slide.
All right, sweet.
So I thought it was just interesting of what a network was. I think initially, when I thought about networking, I guess I was really restricted when thinking about it just like a computer network. I didn't really think about all the things that a network, encompasses and what does it actually mean. So I just thought I would put here, highlight what are we talking about when we talk about a network. We're talking about a regular family system or business enterprise. We can talk about car parts in the car, how they all work together as a network. The telephone system like AT&T, Verizon, Sprint, cable companies like Comcast or MCI or I don't know, Cablevision, government agencies, the Navy, Department of Defense, the regular internet, different networks combined together to make one network. We also have like a Facebook, which is like a network, and just computer hardware itself, how it works together to form an operating system. I just thought that was really interesting that all those things are very different, so to speak, but they all are the basics of what a network is. And when we talk about computer networks, in some way, they all fit that system, whether the way they actually, the network is actually carry out the protocol for the networks. However it works, the foundation of all these networks are all the same, and all the rules pretty much are the same. Ultimately, I thought it was interesting with this whole idea about computer networks that a lot of this networking protocols and systems and structure derived from the telephone system. Came back from back in the day, telegrams, post office, all of our networks all derived from that. So I thought that was pretty interesting. I was going through this as well. So I'll move to the next slide. For the most way, networks are classified in two ways. They're classified either as transmission technology or scale. So when we talk about transmission technology, we're talking about how data is transmitted. Because when we do talk about networking, we are typically sharing data or sharing some type of information. So we can transmit data in two different type of ways. One, we can broadcast it. In that situation, it's like you just have one channel where you have a whole bunch of people listening to one channel. You can think about it like I guess like a PA system in a school. I'm at the beginning of a classroom. Every classroom has a PA system in their wall, and someone in the secretary, I guess around 8:30, they want to give a school announcement. And so they're broadcasting that over the channel, and the channel would be that PA system that's hooked up to everyone's room. And although that information goes to everyone's room, it still only applies to who it applies to. So although you may be able to hear it, but if you're not going to respond to it, you may ignore it or choose not to do anything about the data that you receive. And that's sort of the same concept of a broadcasting network, that we're going to just shoot that information out there, and the people who need it will get the message, and the people who don't. I think what's interesting about it from the computer standpoint is that they're short messages sent in packets. Let's talk about a little bit later on how they become packets. So it doesn't matter how long, or whether it's most things that are broadcast these days are like movies or videos or audio. It doesn't matter how long it is. They're all cut up into short packets. They all have addresses on them, so that when you're putting the broadcast out there, people can identify what package or where that package is going to go to based on the address. And it can be statically or dynamically divided into intervals, meaning that we can divide our data based on preconceived numbers, or we could just divide it based on the amount of data that we have and keep on dividing that based on the amount of data we have and the amount of space that we have, and continue to divide data based on that way dynamically. So that's one way that we communicate. And the other way we communicate is point to point. Point to point is pretty much the most common way. I can't even say it's a common way, but I would say for the web, it's the most common way we communicate. It consists of making many connections between individual pairs of machines. So pretty much you go from source to destination. A packet on this type of network may have to first visit one or more intermediate machines before it gets to its actual destination. When you think about that, I guess that's where it comes down to those algorithms where you talk about finding the shortest path. That if I was trying to get to one network or one computer or one node, there might be 4 or 5 nodes in between there, and I need to figure out which is the fastest way to get the data there. So that's pretty much how the point-to-point work. There's a lot of algorithms that play a point in that. We just talked about that recently, briefly. But pretty much the general rule of thumb for that is that Smaller packets go to they tend to use broadcasting systems, and larger data tends to use more of the point-to-point transfer systems. There's a little bit more information about those systems we'll talk about later on. It makes it, I guess, that will clear up that concept. And the next way that we sort of classify a network is by scale. So if we classify one way how we actually pass our data, or how we transmit our data, it's going to be really important to understand in what network or what groupings how much data can actually be transmitted in that network. So based on that scale on the side there, they have different measurements of how much data could flow in that area, in that network. So the smallest data flow machines are like little portable computers. They probably go 0.1 meters all the way to your local area network, which is your regular LAN. That's like it could be a room 10 meters, or a building 100 meters, or a campus 1 kilometer. You have your metropolitan area network, your MAN. That's your city. Sometimes your enterprises could be a MAN situation. A wide area network would be something like a country or a continent. Will have that. So definitely America has their own networking system. Hence, we talked about in the beginning at the Department of Defense, I guess, but they started ours. And then the internet is just a connection of a lot of different networks all together. That's what sort of forms your internet. And the internet is our entire planet at this point, over 10,000 kilometers. Other little networks that are of interest are like Wi-Fi networks, really small areas. So your Wi-Fi network is really, really small areas. It helps you allow us to be able to use our devices in more portable ways. And internet works. Again, that's more of a collection of networks together. So that's how we classify. So I guess we'll go to the next one. I guess another thing was interesting about network, I never thought about it, was that it broke them down into like two type of, I guess no different than our computer system is broken down into two separate categories. You have your hardware and you have your software. And a lot of the networking that we talk about a lot is just the software and the rules that come along with the software. So I thought that was really interesting as I was going through this. So I guess this is a little bit about the software that we communicate in networks from network to network, from node to node. They have the number of layers can differ based on your network. The name of each layer in the network can differ. The contents of each layer in the network may differ, and the function of each layer in the network may differ as well. So then it goes to the question, what's a layer? So I guess in all networks, they have this concept of a layer or a level. This is pretty much how networks are organized or designed. And pretty much the purpose of the layer or the level is to offer services to the higher layers or levels. And it pretty much encapsulates all the data away from the other levels. So pretty much what it's saying is that when your data moves through these levels, the level only knows what it needs to know. It doesn't know anything else, and it only does what it needs to do. Sorry, guys, I have to pause here for a second, so maybe we can take a little break and talk about what I said so far, because the puppy is ringing for the bathroom, guys. So, there, I guess any comments you have so far about anything I said?
All right, yeah, for sure. Do your thing. So yeah, y'all. I hope so far the stream has been valuable for y'all. If it has, please be sure to leave a like, share, subscribe. It really, like I said, just helps me stay motivated to keep making this content every week for y'all. We try to condense this content as much as possible so that when y'all come to the stream, that we have all of our information ready to go, where you can just sit back and just kind of trying to make this like, I don't want to use the word class, but if it had to be a class, I want it to be the class that you wish you had, whether it's for computer science, coding, tech in general. In this case, we're talking about networks right now. We talk about some operating system stuff in other weeks. So whatever you guys want to learn, I would hope that this just is a class or a learning format that is just helpful for y'all, because we do our best to learn the topics and put these notes together and make it digestible and entertaining or engaging, at least, if not entertaining, but at least engaging for y'all, that you can just sit back and, like I said, just consume the content and expose yourself to new concepts and stuff that maybe you want to go ahead and go research on your own and get more familiar with it so it can stick in your head a little bit more. But for us, we just want to utilize the our time as best as possible, allow myself, and bring our learning together so that we don't have to kind of double dip, and I have to go learn networking and catch up with her, and she's got to come back around and learn language stuff with me. This is our format of kind of dividing and conquering, and then we're trying to share that with you guys. So if this is helpful, really appreciate you guys being here. Just make sure you guys like, share, and comment if you have any questions, and we'll be sure to answer as best as we can, because you guys are who we do this for. So I really hope that this is helpful and that you guys are enjoying this so far. Thank y'all for sticking with us too. Through previous weeks, we've had technical difficulties. I've tried to make this a little bit smoother so that it goes a little better. We don't have so much downtime in the stream. So hopefully, hopefully y'all have noticed, trying to get a little better with that. But just appreciate y'all for sticking with us through all these types of things. I really, really, really appreciate it. Appreciate y'all being here.
Appreciate you too. I'm back.
Let's get it.
All right.
Ready when you are.
All right. So we talked about a layer was so a protocol. So a protocol is really important. All the network is pretty much dominated by protocols and services and interfaces. So a protocol pretty much is just the rules and conventions used to describe how one layer will interact with another layer. It's pretty much an agreement between the two on how they're going to communicate and how they're going to communicate to proceed. Some of these things you'll understand a lot more you understand better as we move forward through the slide. But these are basic definitions of concepts about the network that you need to understand in order to understand more fully about how a network actually works. Then we have the interface. It pretty much defines what operations and services the lower layer will offer an upper layer. The network designers decide how many layers to include in this network and what each layer should do. The most important thing is just making sure that the interfaces are really clean between the layers. Even though I said that the designers decide what the interfaces will do, remember there are protocols for each layer. So designers do have some ability to decide what they're going to do, but not too much. The purpose of these protocols and these layers are so that everyone can communicate with each other and know what to expect. So designers aren't allowed to sort of pretty much just go rogue and just make their own rules to the game. Network architecture is really important. Pretty much the architecture of all networks they're just a set of layers and protocols. Hold on, sorry, losing some area. There you go. They're just a series of layers and protocols. Pretty much they must contain enough information to allow each layer to sort of implement what needs to be implemented. Neither the details of the implementation nor the specification of the interfaces are a part of the architecture, meaning that they're not known. Pretty much all the protocols are in a stack sort of format. They're a list of protocols used for the system. So that's pretty much that. So sorry, but design rules. So pretty much these are just the rules for how pretty much you're designing your network as they go. These are things that you pretty much should include or you should be mindful of or you're responsible for as these networks are designed. And some of the decisions that you pretty much need to keep in mind when you are designing networks. So every layer pretty much needs to be a mechanism for identifying senders and receivers. So again, you'll understand that more as we move along, but pretty much every layer, you're getting information from another layer. So one of the primary responsibilities is for you to know who the information is coming from and who you're sending the information to. So every layer is responsible for some type of a header, where that header is, identifies the source and the destination of the data. Because remember, the whole purpose of the network are rules for how we're going to pass data through a system to communicate to other systems. So there are rules for data transfer. Pretty much, you have certain situations where you have the hardware could only receive data coming one way or two ways, but there's certain rules for it that you need to keep in mind. Error control. Certain protocols require you to have some type of error control to let someone know on the other side if they did not get data. Certain protocols require that you don't need to let other people know if they did not get the data. Messages are broken down into data fragments and frames, and these frames have a certain order. So some protocols is very important that you understand which order these frames came to you in so you can send them back in the same frames. Again, some protocols don't require that. Of course, if you have to know which order the frames come in and send them back, it's going to take you more time as opposed to if you didn't have to reorder the frames in an order when they go back. In addition, you have to manage the fast sending and slow receiver. So if you have internet or a service that can provide data at about 100 MB/s, but then you only can receive your Wi-Fi service or your application or your mobile app, whatever, only receive that data at 10 Mbps, then you need to make sure that you need some mechanism for being able to adjust to make sure that you're not being receiving data too fast that your device can handle. So that's important there as well. You need to also have some type of rules for how you can accept long messages, like we said before, that there's only a certain amount of data that can go for our size as you're moving along these protocols. So if you get some messages that are long, could be video streaming or whatever it is, you have to have a mechanism or way or rules or some way of managing how are you going to handle those long messages so that the communication can continue. Data transmission management, that is pretty much sorry, I have a little brain thought. Pretty much saying that if you when you break the data up into little pieces, you want to make sure that all of them, if you send 8 pieces, you want 8 pieces to get there. You don't want 6 pieces to get there or 5 pieces to get there. So you have to have a way to manage that. And the fiscal management, that these things cost. When you send things fast or how fast they're going to be sent or how much data is going to be sent, it has a cost to it. So you want to make sure that your network is also managing the cost. Now, again, all these things are things that you are responsible for making sure that your network manages when you're creating a network. And all networks do manage this in some way or another. So the final part about the network that we'll get into would be just the reference models. I'm sorry, we got to move to the next slide. Next slide.
Yeah, I think it's just, yeah.
All right. So this is the last part of networking that we're getting for today. This is pretty much just the models that we pretty much use. So the first model that was created for how we were going to communicate was the OSI model. Let's talk. Get out of the way. He has to go to the bathroom. He has to wait. Sorry. I'll get through this before I take him back out to the bathroom again. All right. So the first one was the OSI. I'm trying to, again, I didn't write down clearly. Oh, there we go. So the OSI, I'm trying to get what it stands, Open Systems Interconnection Reference Model. So it's pretty much a model or a way of how, again, when the internet first formed, it was very small. It was only for, of course, first the Department of Defense. Remember, we talked about the areas of the internet. So it was so it was only for the Department of Defense at first. Then when they opened it up to the government and to universities. And that's how the internet sort of opened up to everyone else. So initially, when you have your networks, you don't have that many people in the airways or out there. You only have maybe 100 people or so like that. But as you open the network up more and more, you get more and more people communicating through the network. So now it's important to have some type of protocols so we all can be on the same page to how data is going to be moving throughout this network. And we all know how to use the network in a way. So there were 2 schools of models that came out, the OSI and the TCP/IP. OSI model came out first. The reason why it didn't get as much traction is because the Department of Defense, they came out with the TCP/IP model, and those were the models that were being used in the government agencies in the school. So that sort of took over the world, so to speak, and that's why that is the dominant model of our internet service right now, and that's the model that we use the most. However, the OSI model is very good because it breaks down every step of what is supposed to happen throughout this networking process, and you can pretty much see how TCP/IP sort of does the same thing in its own different way. So, without further ado, we'll move forward. So we'll start from the top to the bottom. So the application layer, pretty much of this networking. So this networking is how data is sent. So when you send data and you communicate to someone, data is sent through these models from top to bottom, and then it goes from the host or from the source from top to bottom, and then it gets to the receiver or the server from bottom to top. So again, if I was on my home web and I was sending out something and I was following this OSI model, I would be starting at the application layer going down to the physical layer, and then if I was sending it to the World Wide Web and I was using something like Heroku to send it that way, they would get it from the physical layer and they would go all the way back up to the application layer, and that's how the person would see it or how the information would be traveled. We'll go through and go down. So the first thing happens at the application layer where you have all the protocols like the HTTP and all that. And those are protocols that talk about how data is going to get transferred from where to where, what's the source, what's the port, all that information. So for most of us who do web browsers and you put your www dot whatever in your browser, and for those of us who write application programs, that's where we put our HTTP requests. Where we're doing our get, post, or put requests, and we're sending that information. That's this section right here. And the information in those headers, the HTTP request, is what the protocols are required to grab that information and pass that information to the next protocol underneath that, or to the next layer underneath that, which is the presentation layer. So again, when the presentation layer gets the packet now, the data packet, they only know the headers. The headers encapsulates the data. So all they're able to see is now the headers of where the source and where the source, where it came from, destination, where is it going, and anything else you have in the headers that's important for the presentation layer to know. The presentation layer has no clue about what type of data, what's going on inside that data, because that's not what it's supposed to know. Its interface only deals with what it needs to know. And this job in the presentation layer is more of the security of it. So it takes that data that we have in our regular raw our regular raw characters, and it turns it into our ones and zeros. It turns into our ones and zeros, that type of data, and then it compresses it. So for those of us who know things like React, and you know about web development in the front end, that's where your data is being compressed. That's where it's being bundled. It's being bundled and compressed at this point right now, being prepared to move to the next level. Once you get to that, you get to from that presentation layer. Again, it now puts its own little headers on top of the other headers, right? So now it's encapsulating the data even more now. And those headers is saying where it has all the information about where it's going to, its addresses, where it's going to the next spot. So the next spot is the session layer. Now this area right here, its job is to keep track of how many people have to interact with this data, right? So if I was sending out data and, I don't know, let's give an example. If I had a house and I was having a house party and I had somebody come over to clean my house, I had somebody come over to set up for, set up for the food, the cooks and all that stuff. All those people are a part of my party. They are part of my session. They're part of that application at that time. They need access to my house for what they need to do, but just for what they need to do. So the session layer is responsible for everyone who needs to interact with that app, and what it does is it keeps track of the session, so who's the addresses of who's there, who's leaving, and it also keeps track of the authentication or authorization, making sure you know who's allowed to be there and making sure the right person is where they're supposed to be at. That's the session layer. When you go down to the transport layer, this is the TCP/IP or TCP/UDP protocol that comes in. This is how data is transferred now. So at this level, I'm sorry, sidetracked with that. But at this level, this is where your data is now being broken down to being transferred over your network at this level. So we get into the connection-oriented and connection list services here now, where the transport layer has responsibility to be able to acknowledge. Pretty much, if you do the TCP, we're acknowledging that. Hey, we're gonna say to the person, hey, can I make a connection with you? That person's gonna send me back saying, yeah, you can make a connection with me. I'm gonna send back over something to that person with the data, and they're gonna send me back an acknowledgement saying, hey, they got the data. So this whole TCP thing is that check and balance thing to make sure your data is getting where it needs to go to. So if something goes wrong and your data doesn't get there, TCP protocol will resend your data. With UDP, we're not doing that handshake. Pretty much we're saying that, hey, this is data you want, I'm sending you that data. If you get the data, you get the data. If you don't, you don't. But, it did what it was supposed to do. It gave you the data. And more UDP stuff is done with broadcasting, where more of your TCP stuff is done with that point-to-point networking communication. Moving on, I'm trying to go with my notes, guys. So now we're at the network layer, and I'm at the network layer here. I'm sorry. Bear with me 1 second. All right, so at the network layer here, this is where the packets come in. This is where we break all our information down into packets and little packets so that we can send it across through the cables or the wires at the physical layer. So pretty much that's what happens here. The data link layer is where we're linking all our packages together, putting them into frames. All these layers have headers and from where these things are coming from. The network layers where we get into our IP addresses and the subnets and all that stuff, making sure that it was going to the right address. The data link layers where we putting all our data in frames, and the physical layers, the cables where we're actually shooting our data like light through, whether it's a copper wire or fiberglass, to where it needs to go to its actual source. And when it gets to a source, it goes through that process from the physical layer up to the application layer to rebuild our data back up so that you can get your data where it's supposed to look like at the application layer. So that's pretty much the OSI model. And the TCP, I guess, where you see the application layer sort of encompasses the application presentation and session layer, is responsible. So we're saying at the application point, we're responsible for all of that. And it makes sense now. If you build full stack applications, it makes sense because you know that you're responsible for managing your sessions, you're responsible for your authentication and all that stuff. You're responsible for all that stuff, your HTTPS stuff, all that before it even gets to the transport level, the TCP or the UDP. So that's one difference where it changed off. And at the bottom layer, the data link and the physical layer was combined as well. So pretty much that's a rough rundown of the networking. I probably talked for about over my half hour 20, so I'm going to pause here with you guys. I don't want to overload you. I think next time I won't have as much for my languages, so I should be able to get my languages and my operating system in at the same time. But definitely feel free to ask any questions or leave any questions or any comments or any feedback for how it could be presented better. And Darian, if you have any questions, I'm open to hear what you have to say as well.
Yeah, I think this was great. This was well explained, this whole flow right here, because I had never actually seen this OSI model before. I always thought in terms of this one over here on the right. So it was cool to hear you talk about what happens at each layer. And it makes sense when you think about it in the coding perspective, like you just said. I'm glad you kind of recapped this part about how full stack developers have to manage the sessions and the HTTP requests and everything themselves, and authentication, everything themselves. So that makes sense. So it's just cool to see like a graphical representation of it, a good walkthrough. And I think it's cool too because I know you got your operating system notes over here as well. But I didn't get to even go into my design pattern stuff because my stuff ran way longer than I anticipated. So I think that's perfect because I think we both will already have content for next week. At least I know I will come with the design pattern stuff. I know your operating system stuff is already done, so I don't know if you want to just talk about operating system stuff next week or if you're gonna have some other stuff in addition to the operating system stuff to go next week. So either way,
I'll probably bring both. I probably do. I start off with operating systems, and if we have time, then I'll get into the X. I'll just continue to bring my slides and the time, and go over what we have time for.
All right, cool. Let me give me one sec before we close. I'm just gonna bring you back real quick because it was. Let me stop this. Go here. I need to go here and stop my live demo mode. And I need to go here and grab scenes. All right, cool. So. All right, you back live. So I just wanted to bring you back so we could, so I could just say thank you for being here again, for sharing all that. I think that was really good information. I'm actually looking forward to getting further into it. It's almost like I was waiting on what was next. I was ready to go deeper into it, like on the networking. So I'm excited as we go forward and kind of just build on what we like. Because I mean, even my stuff I think was good intro stuff. If people have never been exposed to interfaces, abstract classes, concrete classes. Certain things in C#, LINQ, whatever, and then same thing with the networks. I think you gave them a really good introduction to the nuances of what makes up a network, and so now we'll always have this to kind of build on going forward. We'll always be able to reference this video if anybody comes in later down the road. They can always start here and at least see the high level overview. So I think that's why that was really good. I appreciate you for doing that, for having your slides so well structured, and for being here with us.
And thanks, no worries. Anytime, guys.
All right, for sure. So again, y'all, would thank everybody who joined, who's still here with us, who watched this along the way. For anybody who dropped us a thumbs up, I really appreciate y'all. Make sure again you like, share, and subscribe. It helps La and I to just stay motivated, to keep coming back every week and dropping this content, making these slides for y'all. And keep putting this out, helping y'all become better programmers, better developers, and just leveling up in your career in tech. So hour and 15 minutes, y'all. We shut it down this week. We'll see y'all next weekend. I appreciate y'all. See y'all next video.